All right, guys, so we need to finish regression, and to do that, we actually are going to finish these word problems here. So 8, 9, 10, we've only got a couple more. They might be numbered something else on your paper, that's fine. I did reset my calculator, and the first thing I need to do every day when I'm doing regression is make sure that so I press mode, make sure that my stat diagnostic is on, and mine's not, so let's go down and turn it on, okay? Then I'm going to go through, I'm going to type in my values. So I've got in this one right here, I have L1 and L2. And to get there, I'm going to press Stat and Enter. You should be used to doing that by now. All right, so I've got 2, 5, 9, 12, 17, and 19. All right, and I'm going to do L2. So I've got, don't put the commas in, 10,600. 14,200, 20,100, 26,200, 41,400, and 41,400 again. I missed the 4, so I can just go right over it and type it in again. Okay. Now, I need to see, I'm deciding if it's linear, quadratic, or exponential. So we're going to see. Let's press Stat, Calc 4. Okay. Linear is 0.97, so that's possible. Right? Stat, Calc, quadratic. Oh, that's better. 0.98. So quadratic is better than linear. It seems to be it's normally like that. Stat, calc, and 0 for exponential. And that one is 0.9. This one's better. It's 0.989. Okay, so let's write that equation. Because it says find the regression equation, use the equation to answer the question. So y equals, instead of a, we're going to put 9,311.84 times 1.09 to the x power. All right, clear that out. All right, this says, according to the model, what was the value of the investment after 15 years? Round to the nearest dollar. What that means is we're going to take this 9,311 and 80.84 times 1.09, and we're going to raise it to the 15. So it's important you pick the right one and you get the right equation. So what that's saying is Shayna's investment over time will be $33,918. These two pieces are the answers. You do have two answers on these today, okay? All right, let's figure that out. Next, we're going to talk about number 9. If you needed to see that one a little longer, just go and pause it, whatever you need to do until you get there. Move this slightly here. See if I can see. I guess we're just going to have to move it right here. It's okay, it's kind of blocking it. Okay, anyway. The time for the fastest runner for their age in the Marine Corps Marathon is given for several ages. So let's go ahead and find the line of regression or the regression equation. It doesn't mean it's a line. And then use the equation to answer the question. So we will be looking at r squared, or linear, quadratic. I don't know why boxing, you definitely don't have to, and exponential. All right. So stat, edit. Remember, we just are going to press delete till these are all gone, and delete till they're all gone. So 17, enter. 31, enter. 33, enter. 40, enter. 53, enter. 58, enter. All right, then go over. 197, enter. 149, enter. 151, enter. 159, enter. 178, enter, and 185, enter. I do want you to notice something. Notice how this one, so the ages just go up, but the times start high and they go down, and then they start to go back up, okay? Think about the type of graph that starts somewhere, goes down, and comes back up. It's good to think that way. Also, it'll help us to decide if what would be the time for the fastest 25-year-old, which should fall in between here. So it should be between 197 and 149. It's something to think about. Make sure we have done the question correctly. For instance, over here, 15 years was in this area, so 15 should have been in here. Does it make sense that 33,000 is there? Yes, because it's between 26 and 41. If it was bigger than 41, that probably would have been a problem. All right, anyway, so let's press and find our square values. So number 4 is really bad. This is not linear. 0.002. I don't even need to write that down. If you don't have one better than this, I probably made a mistake somewhere in the typing in of the list. All right, stat, calc, number 5. Oh, that was pretty decent, 0.91. Okay, let's see if exponential is better. Nope, that one's terrible as well, 0.006. So it's definitely quadratic. So let's go back to quadratic, number 5, and write the equation. So y equals 0.097x squared minus 7.35x plus 291.35. Okay, now clear this out and let's see what it asks. Using this model, what would be the time for the fastest 25-year-old? Round your answer to the nearest hundredth. So we are going to plug in everywhere we see an x. We're going to put 25 squared minus 7.35 times 25 plus 291.35. Okay, we run to the nearest hundredth, so the fastest time would be 168.23 minutes. Let's see if that makes sense. Is that between 197 and 149? Yes, it is. So we've probably done a good job. Which kind of funny there. That falls in between the 50s range. So it looks like the fastest is around 30-ish, 31. All right, last one. I would pause the video. You try this one on your own and see what you get. Answer the question. We've paused it. We've sorted these cards where they go. Let's see what we got going on. So stat, edit, and delete everything. So 1963, 1967, 1974, 1988, 2000, 2005. 608, and that's hectare, kilogram per hectare. It is a unit of measurement you're not used to. We usually use acre. 741, enter. 1,130, enter. 1,370, enter. 1,440, enter, and 1,750, enter. All right, stat, calc, 4. Ooh, I messed that up. Do not do what I just did. So if you ever do that, you can just press second, and this little one right here, it replaces it with L1. It should be L1, L2. Like I just accidentally did. Okay, R squared is for linear is 0.93. That's pretty good, actually. Let's try quadratic. Stat. Calc 5. 0.95. That's better. Exponential. Stat. Calc 0. 0.88. So it's quadratic again. Okay, I'm going to tell you something. We're not going to use quadratic in here. No, hang on. That's not what I'm thinking. Scratch that. Can I say? We're going to look at quadratic, and I'm going to tell you something. If something is messed up, we're not going to do this. No, it's fine. If we have e to the negative a whole bunch, we're not using those. We will go to the next closest one. Okay. The reason for that is because that decimal is so small, we're not going to use that one. But anyway, so let's go. It's y equals negative 0.35 x squared plus 1,431.86x minus, that huge one, 1,442,921.91. It's very large there. Okay, so clear. It says, according to the model, what was the crop yield in 1981? So negative 0.35, parentheses, 1981 squared plus 1431.86 times 1981 minus 1,442,921.91. Okay, I feel like I did mess up. And I know, here's how I know I messed up. So do you see how I got 20,000 and I'm looking at 1981? That doesn't make any sense, okay? That means I definitely messed up. So I'm going to go back up here and I'm going to see where I messed up. And if I don't notice where I messed up here, I might have to go back and look at the equation, make sure I wrote it correctly, okay? But it just doesn't make sense that it would be that big. So does my number match 1442921.91? Yes, it is minus. Okay, 1431.86. That's fine. And I did put in 1981. I did add it. Okay, negative. Did I put negative 0.35? I did. All right. So let's clear this and let's go make sure I wrote the equation down right. Okay. Negative 0.35 x squared. 1431.86x, yes. Negative 1442921.91. Let's type it in one more time. Typing it in doesn't work again. We might need to go use the linear one. Maybe this doesn't really represent it because we shouldn't get something that doesn't fall between. If we don't get something that falls between, we haven't found the right thing. No, that's 1981. I'm typing in again just to make sure. Sometimes you might have made a mistake and you just can't find it. Minus 1,442,921.91. I got the exact same answer. And it should fall right in here. So let's write the linear equation just to see if we get a number that makes sense. And if we do, then we're going to cross out the other one and decide it's linear. So let's try that one. Okay, so y equals 23.99 x minus 46,390.50. Let's try this one. If this works, the reason it works would be, and the reason this wouldn't be a good fit is, maybe every now and then there's an outlier extra number. We're going to talk about outliers next week after this, but some things can happen sometimes. So 1981 minus 46,390.5. That makes sense. Think about it. So it's right here. Here's 1981. It's 1,133. Well, that's slightly bigger than 1974. So we're not going to use this one. So 1134. Nearest whole number. There we go. So now that you have word problems, it's easier to check a number to make sure it works well. Okay, so there's a couple of things to look at. All right, go ahead and put your cards in the correct pockets and get started on the assignment.